Hi, everyone. We're continuing with section 4.7, and we will now evaluate inverse trig functions. Again, in the beginning, let's talk about our big daddy sine function. Imagine this sine button on your calculator, and put your calculator in radian mode. Now, this sine function will let us input basically angles in radian measure. They can be thought of as just real numbers, but let's think of these inputs as angles in radian measure. So for example, we can input pi over 2 radians and evaluate the sine of pi over 2. Well, the sine of pi over 2 is going to be what? It's going to be 1. Sine of pi over 2 is 1. In case you forgot why, we can think of the unit circle. Pi over 2 is this point up at the North Pole. We want the sine value. What's the y-coordinate of that point? It's going to be 1. Sine of pi over 2 is 1. Also, if you remember that trick we talked about in section 4.2, sin at pi over 2, the sine of pi over 2 radians is 1. Think of that I representing 1. All right, sine of pi over 2 is 1. We input pi over 2 into your calculator, you press the sine button, and the output is 1, which is a sine value, a number in the range of the sine function. Now let's say we want to invert this process. What if we take the inverse sine button on our calculator? It might be a shift sine operation, for example. But we take this inverse sine button or function on your calculator. We see 1 in our calculator display, or we input 1. What then will be the output? Well, if you have a fancier calculator, it should output pi over 2 radians, or just pi over 2. And why is that? Because the inverse sine, or arcsin, of 1 is pi over 2. And that makes sense because of 2 reasons. Because the sine of pi over 2 is 1. As we mentioned earlier, that's what this was saying. Sine of pi over 2 is 1. If you input pi over 2 into the sine function, the output is 1. Now I'm claiming that if you input 1 into the inverse sine, or arcsin function, same thing, the output is going to be pi over 2. In part because sine of pi over 2 is 1. Remember that when you write down an inverse statement, you're basically switching the inputs and the outputs. Sine of pi over 2 is 1, so we may be able to say that arcsine of 1 is pi over 2, or inverse sine of 1 is pi over 2. But there is a second condition. We have to make sure that this angle that's being spit out is in fact in the range of the inverse sine, or arcsine function. Remember that any function is only allowed to spit out a value, is only allowed to output a value in its range. Well, the inverse sine, or arcsine of 1 is pi over 2 because pi over 2 is in the range of inverse sine. Inverse sine is allowed to spit out pi over 2. So there are 2 reasons why the inverse sine, or arcsine of 1 is pi over 2. Because sine of pi over 2 is 1, this switching works. One here, 1 there, pi over 2 here, pi over 2 up there. And because pi over 2 is in the range of the inverse sine function. Now remember, pi over 2 was in the restricted domain of the sine function. Remember, when we restricted the sine function, we went from negative pi over 2 to pi over 2. Pi over 2 was legal. It was a legal input. It was in the restricted domain. And when that happens, this loop-to-loop works perfectly. We start with pi over 2, input into the sine function, the output is 1. And then if you take 1 and input into the inverse sine function, the output is pi over 2, which is the same as the original input at the very beginning. This loop-to-loop works as long as pi over 2, as long as this angle here, is in the range of the inverse sine function. Then this works perfectly. Basically, we're saying here that the inverse sine or arcsine of the sine of pi over 2 is pi over 2. You input pi over 2, and the ultimate output is pi over 2. We'll talk more about these inverse properties later. In the next video, we're going to evaluate some more inverse trig functions.